continue. So here, as we can see, if you want to calculate the average force acting on this torque, you can multiply the average stress by the area of application. So it will be the average stress, which we can calculate from K and N, times the area on which it's applied, which is W, the width, times the contact length F. Okay, and the contact length L can be approximated function of the radius and the thickness variation by the following formula. It can be, since the angle is very small, we can calculate this length as R times T0 minus T final. Okay, so in this way, knowing the radius and knowing the initial and final thickness, you can calculate the value of L, and multiplying by W and average stress, you can get the average force. So let us see here the formulas. We have an approximation of the results obtained in the integration equation can be calculated based on the average flow stress experienced by the work material in the roll gap. So F is the average flow stress times W times L. And the average flow stress is in megapascal in SI unit and in LB per inch square in English units. And the WL represents the roll work contact area, which can be calculated in meter square or millimeter square in SI and in inch square in English units. And as we said, the contact length can be calculated through the following formula, radical R times T0 minus TF. Now, we will see that this force can be used to calculate the torque and power required to provide to the rolls. So knowing the force, how we can calculate the torque needed? As you can see here, you can consider that the force is, the resulting force is passing through the center of the contact area. And in order to ensure the rotation here about this point, I need to provide a torque equal to this force times this perpendicular distance. Okay, this one. Now, since theta is small, I can consider that the arc of circle length is equal to the segment length. So this segment can be approximated as L over 2. So the torque required for rotation of one roll is the force F times L over 2. So if I want to find the total torque for the two rolls, I just multiply by 2. And I get that the total torque should be F times L. And therefore, I can calculate the total power, because you know that power is torque times what? Power is torque times angular velocity. Or power is, in other words, it's force times linear velocity. Okay? So the unit of power is watt or joule per second. The unit of torque is Newton meter. And the unit of angular velocity is radian per second. So as you can see, radian is no unit. So Newton meter per second is joule per second. Okay, so the power can be computed as the total power that should be provided to the two rolls is the total torque times omega. And the total torque is F times F. Okay, so we can see this in formulas here. So the torque in rolling can be estimated by assuming that the roll force is centered on the work as it passes between the rolls, and that it acts with a moment arm of half of the contact length L. Therefore, the torque can be calculated for one roll. Please pay attention. So if they ask for the torque for one roll, it's 0.5 L. If they ask for the total torque, it's 2 times 0.5 L, so it's F times L. Now, the power required to drive each roll is the product of torque and angular velocity. Now, how to calculate angular velocity? In general, they gave us the rotational speed N. The rotational speed N will be in general in revolution per minute or revolution per second. In case if it is in revolution per second, we know that in the formula of power T times omega, okay, T is in Newton meter and omega is in radian per second. So to have omega in radian per second, all we have to do is to convert from revolution to radian. And we know that one revolution is 2 pi radian. So all I have to do to get omega is to multiply n by 2 pi. So the angular velocity is 2 pi n, but please pay attention to do just 2 pi n should be in revolution per second. If n is in revolution per minute, I should multiply by 2 pi and divide by 60. Okay, so pay attention for units. Where n is the rotational speed of the roll, therefore the power for each roll will be 2 pi n, yani for the two rolls, if you want. For each roll, I have pi n t. For the two rolls, I get 2 pi n t. Okay, so so in total, the total power, okay, will be 2 pi n f times f, because for each roller I want 0.5 L times 2 pi n. Okay, so if I multiply this result by 2, I get that for two rollers I need 2 pi n f L as power, whereas for one roller I need pi n f times f. Now, as we said, for units, power is in watt or joule per second. In case I work in SI units. In case I work in English units, it is inch lb per minute, or sometimes feet lb per minute. So it depends on the value of length given. The rotational speed in general is provided in 1 over second or revolution per minute. So it depends on the given. And the rolling force is in lb, or of course the Newton in SI units, and the contact length meter or inch. So this is the formulas we will do practice on Wednesday for chapter 15. Now I want just to tell you also that on Blackboard you have an equation summary sheet for all equations in chapter 14 and 15. So as you can see here, we have passed over all of these formulas. So the true strain is ln L final over L0. The flow stress is K epsilon to the power n. The average flow stress is K epsilon n over 1 plus n. The strain rate is velocity. For example, if we have a certain operation, it's the ram velocity and h is the instantaneous height. And the strain rate sensitivity equation is given by y equal to c times epsilon dot to the power n. Here it's epsilon dot. I mean, the point is not clearly shown. Epsilon dot. Okay. Now in rolling operation, we have today defined the different terms for rolling. We have the draft, which represents the variation between initial and final thickness. The reduction is the ratio between draft and initial thickness. The maximum draft per pass, so please pay attention. Here, this is per pass. So you might need to do several passes to achieve your final draft. So Dmax per pass is mu squared times r, where mu is the friction coefficient and r is the roll radius. So if you have a certain draft higher than d maximum, then you should do several passes, and the minimum number of passes required will be the ratio of the T0 minus T final over the draft per pass. Concerning the conservation of mass, it will give you a relation between the thickness, the width, and the velocity of the work part at the initial and final state. Now, for the tangential speed of the roll, we can calculate it from omega of the roll times r. And you know that the angular velocity of the roll is 2 pi n. Of course, n in this case is in revolution per second. Another parameter that is important in rolling is forward slip. It represents the ratio between the difference between Vf minus Vr over Vr. And in order to calculate the force, we need the contact length. The contact length between the work part and the rolls can be computed from a radical r times T0 minus Tf, where T0 minus Tf can be replaced by d. Now pay attention here. This is the contact length for each pass, okay, per pass. Now, concerning the rolling force is calculated as the average flow stress times L times omega, and the torque is computed from for one. Please pay attention here. This is the torque per roll, okay, for one roll, and you should understand the method to know each formula is for what. So this is for one roll. while here the power is given for here for 2 rolls. Okay, because P is T times omega. This is omega, and here they give you T, the torque for 2 rolls. So this is the power for 2 rolls. And here, why they did 2 pi n over 60? You should pay attention here that if I do over 60, this means that n is not provided in revolution per second, but in revolution per minute. And in order to convert it to, so to convert to radian per second, I should multiply the value of n by 2 pi and divide by 60. Okay, so if n is provided in revolution per second, no need to divide by 60. I just do 2 pi n fl. But if n is provided in revolution per minute, I should divide 2 pi n by 60 to transform it, to transform n from revolution per minute to radian per second. Okay, any question on this? So we will practice on these formulas together next time. Okay, on Wednesday, hopefully we continue problems of chapter 15. See you next time. Bye.